Hi, we'll be presenting Project Idea 15, Digital Crime Analyzer. My name is Jie Kai, and I'll be talking about the overview, problems, and solutions of this project. Digital crime is facing a meteoric growth. In digital crime investigations, investigators and incident responders are often required to examine and analyze log records to identify criminal behavior. Traditionally, the process involves painstakingly examining various log files, digital trails, or artifacts extracted from disk or memory images, consuming large quantities of time. Therefore, a data-driven analytical solution can provide crime investigators clear, consolidated, and precise behavioral patterns in shorter periods of time. The goal of this project is to develop an application to assist cyber investigators to better comprehend digital behaviors with a variety of characteristics and assist people with limited cyber expertise to get critical insights, such as identifying whether a host or network has been hacked, in the form of a compact, user-friendly, and dynamic solution. This slide shows our project cycle stages, from prototyping with our own simulated dataset for exploration to gathering realistic datasets, creating our own tools, and integrating them all into a single GUI application.
Hi, my name is Marcus, and I'll be covering the algorithms developed for our application. Our brute force detection via Windows Event ID algorithm filters events IDs from Windows log related to the attack vectors employed, such as user login events ID 4624 and 4625. Our deep packet analysis algorithm will take raw text data and categorize individual packets according to the type of protocol with which the packet is linked. This aids in cleansing the categorized data and producing a structured format that may be utilized for generating the machine learning model for attack detection. The detection of a network communication between two networks algorithm will take raw text input and convert it into conversation in the network by categorizing source and destination IP packets. Packets are enumerated to yield the overall packet counts for each conversation. Our machine learning algorithm has been integrated to assist in identifying patterns and make decisions with little human intervention. Machines should ideally improve accuracy and efficiency while eliminating or greatly reducing the possibility of human error.
Hi, my name is Kang, and together with Shitan, we'll be briefly explaining the various toolsets we have developed. Our first toolset is a conversation packet statistical visualization. This visualizer represents the highest packet counts from conversations between different IP addresses, source, and destination. From this, we can analyze which conversations are abnormally dense, which is an indicator for high network traffic, allowing viewers to quickly narrow down the possible leads for threats such as DDoS attacks for further in-depth analysis. Next, our network protocol activities and statistical visualizers returns us the popular network protocols detected in our dataset. Users can filter the data based on search criteria such as source IP, destination IP, and time intervals in the form of a pie chart. Additionally, a second graph displays the same number of packets encountered within the given interval to paint an image of the various network protocol activities over time. Lastly, a table then displays counts for these IP sources and destinations based on search protocols to review IP addresses with a high number of conversations based on the user's filters. Next, I will pass the time to Sutan to talk about our next set of tools.
Next, we have a machine learning visualization tool, which gives suspicious scores to packets with the help of our machine learning algorithm, which assists the investigators to discern if the conversation with our host indicates any suspicious activity. Our brute force scatter plot detection visualizer showcase a timeline of events that occur in a Windows machine. This allows the investigators to visually analyze digital crime patterns with ease. This 3D scattered geograph visualizes where the conversations with the client host is coming from around the world. This feature will aid our cyber investigators to know more about where their adversaries are coming from. This event ID activity overview and count statistics graph and table gives a bird's eye view of the activities in our dataset to identify any unusual behavior, and it also has filtering capabilities to return specific unique event IDs for analysis. Lastly, we integrated all the above mentioned tool sets into a user-friendly GUI application. Next, I'll hand over the time to Jiazhe.
Hi, my name is Jiazhe. I'll be covering the demo part for the digital crime analyzer. So for this demo, we'll be utilizing two categories of file. One is the network packet, which is the .pcat file. And the second one is the Windows event log file, which is the EVTX file. So by running our application, as you can see in this GUI, we have created it for the criminal investigator. Let's go through the data for the Wednesday brute force. So as you can see, upon successful upload, you will come into this browser. There's two part of the report. First, I want to cover is the top 10 conversation count report. So you can see the top conversation, it straight gives you a broad overview of what happened in the network. For example, the top conversation call ratio. So by having the geolocation chart, you can see what a adversary or like who is connected to you from where around the world. And you can see the ratio of the normal traffic to the suspicious traffic, which is quite important. So not only that, we provide an in-depth packet analysis for the criminal investigator. First of all, there's a search function, as you can see. You can search by the source IP if you already know who you are looking for and what protocol it resides on. As you can see, at around approximately 10:33, we detect a high volume of traffic. This means that, hey, something wrong with your network. And verifying from the website, as you can see here, Wednesday, hey, 10:32, they did indeed launch a cyber attack on the network. So this proves that our application report is actually quite accurate. So now we will move on to the Windows event log. Okay, so for the Windows event log, same. Come to this application GUI, attach the file. As you can see, this one is a brute force detection summary page. So first, moving on into the Windows event summary, as you can see, there's so many data right here. This consists of all the Windows event ID that have been triggered. To move on, we further implement a brute force detection. So when clicking on this page, there is no trace of any relevant event ID that was found that was related to brute force, particularly SSH or FTP. Now we will be moving on to the Friday DDoS attack. The same procedure, user must always upload a file. So as you can see, we downloaded this one. It's around 198 MB, but it's too big for our analysis. It will take quite a while to load. So for the sake of the demo purpose, we'll just use a smaller one. So after deeper analysis, as you can see in this graph, there's a lot of connection made to us from other country, which should not be the case for any internal network. When we go into the deep packet analysis, it will return the result that it will show what time that it was the high volume traffic started. The investigator can actually just download the PDF, which will capture the whole screen of this browser right here, and they can use this PDF for further investigation or do a report summary to their superior if needed. So on top of that, not only our tools have this analyzer, we have an additional feature for port scan. We can scan unused port that are open that will be part of a vulnerability in future. So such unused port are normally recommended to be closed if they are not in use, especially for Windows servers. So this is part of a cyber tool that the investigator can bring out to just check. On top of that, this GUIs provide us a about page, which the criminal investigator, if they do not know how to use the tool, they can always refer to the user guide as shown right here. So with that, I have done the demonstration. Now I'll be passing my time back to Jia Kai. Thank you.
In reference to our results from the demonstration, we can infer insights for the datasets analyzed. On Wednesday, our analyst shows only one destination address, 172.31.69.25, while the number of source addresses are many. No evidence of the internal host being compromised was found. In conclusion, the malicious connections were most likely captured and mitigated by an IDS or firewall deployed at the entry point. On Friday, based on the analysis of the network data, there was a DDoS attack. A DDoS attack is a distributed cyber attack in which the perpetrator seeks to make a machine or network resource unavailable by disrupting services of a host connected to the internet by flooding the bandwidth with conversation packets via multiple computers. In conclusion, the usage of our tool provides useful data as shown in our analysis report to help cyber investigators better understand digital activities and inform them about the network state. For future improvements, we can explore additional detection algorithms and visualizations for other categories of cyber attacks to expand the use and capabilities of the solution, such as a machine learning model for detecting DDoS attacks. As a result, with our application, a good data-driven solution can benefit crime investigators to better understand digital behaviors with various features. We have come to the end of our presentation and demonstration. Thank you for your kind attention, and I hope this presentation has given you an insight to the benefits of our application. Thank you.